Question 5. Given the quadratic equation, this one, where r is a non-zero integer. Don't get confused by this. They're saying that r is not zero lah. Find the value of r such that one root is the negative of the other root. Okay. So let's look at this equation first. So from here, this is the quadratic equation lah. So from here, this is our A, this will be our B, and this will be our C. So I can write it here. A is r, B is r minus 1, and C will be 2r plus 3. Okay. So now if one root is the negative of the other root, our roots will be alpha and negative alpha. So from here we can find sum of roots. Sum of roots will be alpha plus negative alpha, which is 0. And then our product of roots will be alpha times negative alpha square. Okay. Then we must know that sum of roots is also negative b over a. And product of roots is c over a. So this is our b over a. So we can say negative r minus 1 over r equals to 0. Therefore, we times this here. So negative r plus 1 equals to 0. Therefore, r equals to 1. You can double check by doing POR. So C is 2r plus 3, this is C, over r equals to negative alpha square. Oh, cannot lah. Here you have two unknowns. So here we don't need to find the alpha. We only need to find the value of r. So no need to do this. Just this enough. R is 1. Okay. Let's look at B. One root is the reciprocal of the other root. Okay, reciprocal means one root is alpha, one more is 1 over alpha. This is reciprocal. So our sum of roots will be alpha plus 1 over alpha. And our product of roots will be alpha times 1 over alpha. So this will give us 1. This will give us in terms of alpha, so we cannot really solve lah, because you have unknowns r and alpha. Two unknowns you cannot solve. Here we can solve because we already got the number. So POR is C over A. C is this, A is this. So 2r plus 3 over r equals to 1. Multiply the r there. 2r plus 3 equals to r. 2r minus r is negative 3. Therefore, r is negative 3. That's it. This part no need to do. Okay. Let's look at question C. One root is twice the other root. So the roots will be alpha and 2 alpha. Twice the root lah. So 2 times alpha. So the sum of roots will be alpha plus 2 alpha, which is 3 alpha. And the product of roots will be alpha times 2 alpha, which will give us 2 alpha square. Okay. So sum of roots is also negative b over a. So negative b r minus 1 over a. This one, product of roots will be c over a. So c will be 2r plus 3 over r equals to 2 alpha square. Alright. So now we have two equations with two unknowns. So we have to solve them simultaneously. Let's erase this first. Okay. Elimination might be a bit difficult, so we try substitution. Okay, what we can do is we can make alpha the subject. So 3 we bring here will become divide, so it will become 3r here. So negative r plus 1 over 3r equals to alpha. So now we got alpha already. We can sub this alpha into here. Okay, let's try. So 2r plus 3 over r will equal to 2 alpha square. So negative r plus 1 over 3r square. Okay, delete all this first. Okay, now we expand. So this will become 2r plus 3 over r. This will become 2 negative r plus 1 square over 3r square. Oh wait, let me just expand lah. Okay, let's just expand. So negative r square is r square. 2 times this will be negative 2r, and then 1 square is this 1 over 9r square. Then 2r plus 3, we expand the 2 inside over 9r square. This and this we can cut one of the r's, then we cross multiply. So this one will times here. 9r times 2r plus 3 equals to 2r square minus 4r plus 2. Okay, we sambung here. So this one we expand, we get 18r square plus 27r equals to 2r square minus 4r plus 2. Then we bring all of this to one side. 18r square minus 2r square plus 27r plus 4r minus 2 equals to 0. So 18r square minus 2r square is 16r square. 27 plus 4 will be 31r minus 2. So from here, we try to factorize it. 16, 31, negative 2. So r is negative 2 and r is 1 over 16. So putting them inside the bracket, we get r plus 2 and 16r minus 1. So our r values are these two. This will be our final answer. That's it. We get two different values of r.